Hey, we're going to talk about designing reactive Angular components. My name's Deborah Kurata. I'm a software developer and Pluralsight author, and here I am in one of my favorite places on the planet. Any of you all fans know where I am here? All right, so reactivity, designing for reactivity. What do we mean by that? What do we mean by a reactive component? Let's start by looking at a demo. Okay, so here are my Star Wars vehicle sales. You want to buy a speeder? Okay, so if I click on vehicle list, I get my list of vehicles. And here I have a list of classifications. When I click on a classification, it reacts by filtering the list. That's what we mean by reactive. When I click on one of the filtered vehicles, it reacts by turning blue and also by showing that vehicle's detail. When I click Add to Cart, it reacts by showing the number of items in my cart here. So my system is reactive. It is reacting to my actions. So I'm going to add another one. And I now have multiple items in my cart. So when I click on cart, it's going to show me my items in my cart and my cart total. If I then change my quantity here, if you look over at the cart total, it's 109,000 units. If I, credits rather, if I click on 2 here, you can see that the amount changed and I'm getting free delivery now. So it's reacting to those changes. If I click X here and remove that item, it's automatically reacting, and now I have a delivery fee because I haven't spent enough to get the free shipping. So that's what we mean by reactive. So we want our shopping cart to be able to react to changes. When I change the quantity, I want it to change my totals. When we implement our designed reactive components, we'll use reactive programming. Reactive programming is a declarative programming paradigm concerned with data streams and the propagation of change. Saying it another way, code is reactive when an input change, such as changing the quantity of our speeder, leads to an automatic change in the output. Okay. What are some advantages of using a reactive approach? Why would we want to design our components to be reactive? Well, first of all, it allows us to better react to user actions. We can also compose streams of data, and we'll take a look at that in a minute. We can communicate between components. So our cart component didn't need to know anything about our menu, but our menu was still able to show us the number of items in our cart without having to be closely coupled. So it provides this mechanism by sending out notifications that we can keep the different components in sync with the same data. And of course, we can manage application state. In this example, we are managing our cart. So how do you design for reactivity? Well, we want to consider data flows. We've been doing that since the beginning of time, right? Whenever we do any kind of software, when we're thinking about the design of a component, we think about the data that flows through it. But added to that, if we're going to design for reactivity, we also need to consider how that component is going to react and how it's going to propagate changes. Lastly, depending upon the organization that we belong to, we may need a way to validate our reactive design. So at the end of this talk, we're going to look at a technique that you could consider using for that validation step if you're required to do that. Okay, so data flows. What do we have to think about? Where does the data come from? Is it from user entry, an HTTP request? If it is an HTTP request, does it come back like we want it, or are we going to need to do some manipulation of it? Or is it being calculated? We also want to think about where the data goes, right? Is it needing to go to another component? Do we need to notify other components of this change? Or is it going to a backend server somewhere? When considering reaction and propagation of change, we want to look at what the source of that change is. Is it a user action, an HTTP response, For example, let's say that the user logs in, types in their username. We take that username, we issue an HTTP request to get the user record. We get that response back, and we need to have that change recognized. We need to be notified that we've received that response, and we need to react by getting other information now that we have the user record. With the user record, we have the user ID, and we can get the user's preferences or favorites or whatever that we need to retrieve. Then how should the application react to those changes? Should it issue another HTTP request, like in the scenario we just talked about? Does it need to recalculate or simply redisplay? Let's work through designing these components, again, using our example application. Let's start with our vehicle list component and look at its data flows. First of all, it needs all available vehicles. Where will that data come from? What will it look like? Does it have everything we need? Well, in this particular case, we are getting all of the vehicle detail when we display the list. We also have this vehicle classification drop-down here. So again, where will this data come from? What does the data look like? Does it have everything that we need? Well, in this particular case, our endpoint does not have a list of vehicle classifications. We could instead then filter through our list of vehicles to pull those off, or we could just find another way to obtain and maintain those. In the sample app, I've just hard-coded those in. Okay, reactivity. How is this thing going to react? Well, what happens when the user picks on a classification? Well, when the user picks one, we want to filter the list to that selection. How are we going to do that? Well, first of all, we need to be notified of the selection. Then we need to filter to the vehicles that match that selection. Whenever we hear notification that we're going to need to provide a notification, then we need to be thinking subject or behavior subject. Here is the two-line pattern that is normally used for defining a subject or a behavior subject. Here we're using a behavior subject because we want it to emit right away. We want it to have a default value of an empty classification. So we're using private to keep our subject encapsulated in our service that's supporting our component. And then we're exposing our vehicle class as a read-only observable so that any other part of the code can subscribe to that and receive these notifications. Then we'll have a method in this same service that knows how to emit into that behavior subject. And in this case, we're going to emit the string that is that vehicle classification. How do we then use that selected class to filter the list? Well, let's think about that a moment. What do we need in order to filter a list? First of all, we need the list. Second of all, we need to know what we're going to filter it with, that string classification. So as soon as we know we're going to need to be working with two streams, we know that we're going to want to try combine latest and see if that would work for us. So we're combining all the vehicles, which is the retrieval of all of the vehicles, the result of our HTTP request. And when the vehicle class changes, we're going to have our list of vehicles change to meet that classification. So down here, we're doing our filter, and if the class includes the selected class, we return true. If the selected class is empty, we also return true to return all of them if there's no specific class. All right. The vehicle list also has another reactivity component to it, and that is that when the user selects a vehicle. So the user is going to pick a product here, a vehicle, and it's going to highlight that selection and then also display the detail. How do we display that detail? Well, first of all, again, we need to be notified of the selection. The detail component needs to be aware of the fact that someone on the list component picked something. So we need to have that notification. Next, we need to get the vehicle detail and the related films. So first step is notification. Again, when we hear notification, we think we need a subject or behavior subject. Again, we're going to do a behavior subject so it emits right away. and we're going to have our code that is going to next into that. Now, in a real application, we should be using an ID. Our vehicles at this particular endpoint did not have any kind of identifiers, so we're using the vehicle name. But if you were doing a real production quality application, hopefully your data has some kind of unique identifiers, not just names. Okay, next we need to react and propagate the change. So here, every time the selection changes, this observable is going to emit. And what we're going to do is take that vehicle name and we're going to issue an HTTP GET request. The emitted item, so that selected vehicle name, is what we're using as our query parameter. Now, if you've been noticing here through all of my declarations, I am using a declarative approach, like we talked about at the beginning of this talk, to define all of my observables. So I don't have subroutines here that I call. Instead, I'm just using declared variables that can change and can propagate the change. When I talk about doing a declarative approach, one of the first questions that I get is, but Deborah, how do I pass in this vehicle name or whatever that I need as a query parameter? And the answer is that we pass a parameter by instead emitting it into an observable. So here it's going to emit that value. We have the value then that we can use. And again, it would be better if it was an ID to go and search for that. Okay. The vehicle detail, we haven't talked about its data flow yet. So we need both the detail information from the vehicle, but we also want the list of related films. So how are we going to get that? To retrieve related data, we can again use the observable. When the observable emits, we're going to get the related films. So a tip here, to retrieve the related data, we want to use a higher order mapping operator, such as switch map, that will automatically subscribe to our inner observable, the one that's inside our pipe. It will automatically subscribe to that for us and handle the unsubscribe. So in this example, then, we are filtering out empty values. That's what this does. So if the user hasn't picked a selected vehicle, it won't try to go get anything. Then we're switch mapping on the vehicle. The vehicle has a set of films, potentially more than one. So we're using a fork join, so it will return the result of all of the gets to get each of the films. It will return them all as an array. So it emits an array of films. Okay, our cart component is the next one we're going to take a look at. Its data flow. Well, in our particular example, we don't have any pre-existing carts. We don't store a cart. So if you refresh, you're going to lose your cart in our sample application. So maybe your cart, actually, you would save it somewhere and go get it. But for our purposes, our data flow is that you start with an empty cart and then you add items to it. So that's where the data is going to come from. It's going to get built. But does the data have everything that we need? Well, we can kind of think of our cart as a list of vehicles, right? Because that's what we're buying. We're buying some list of vehicles. But if we just were storing the list of vehicles, we wouldn't have the quantity or the cost. Now, we don't need to store the cost because we have the price and credits. If we store the quantity, we can calculate the total cost or the extended price. But how are we going to store that quantity? So we can look at our cart data. We could think of our cart as an array of vehicles, but then how do we track that purchase quantity? It might be better to instead treat our cart as an array of cart items. Then our cart item is the vehicle, whichever vehicle that they've put into the cart, along with the quantity, how many of them that they want. Now, the other thing that we want to think about with regard to our cart is we're going to want to do CRUD operations, right? Create, update, create, read, update, and delete, CRUD. So we also want to deal with some kind of state management operation. So we're going to define a third interface here, which is an action, and it uses a generic parameter of type T. It allows us to use this interface for any kind of data that we need to manage if we want to retain its state. So we could, if we only needed it for cart item, we could use cart item here instead, and we'd have our cart item and our action. But by having it a generic parameter, we could also use this if we wanted to maintain customers or user preferences or any other kind of data that we wanted to maintain in our application. But how do we add the item to the cart? So we have now our interfaces, but how do we actually add the item? Well, our vehicle detail component had some reactivity where we click the button to react to the action. We're going to add it to the cart. How do we add it? Well, first of all, again, we need to be notified of the action. Then we need to add the vehicle to the cart. Now, we also might want to do an update if the user updates the quantity, or a delete if the user deletes the item from the cart. So we're going to have all of our CRUD operations that we'll need to do. First of all, we're going to want that notification. And again, when we think notification, we think, okay, we're going to need to create a subject or behavior subject. Here we're defining a subject of action of cart item. So that's going to define what's going to be emitted from our subject. And then, of course, we have our read-only as observable part. So when we add to the cart, we're going to actually emit this value. And our action looks like our item, which is our vehicle and our quantity, and our action, which to add to cart will be add. Okay. Then we need to react and propagate changes to the cart. So how do we do that? Well, first, we want to use a scan, because a scan will maintain the array of cart items. So whenever we want an observable to hold on to values, we can use a scan. Now, one of the differences between a subject and a behavior subject is the behavior subject will always remember the last emitted item. Scan works similar to that, where it will always remember its accumulated value, whatever that is. In this case, it's our items, it's our cart items. And then the second argument to the scan is that change that you want to do to it. So that's our item action. So that would have, do we want to do an add, update, or delete, and also the cart item, which is the vehicle and the quantity. Then we're going to call this method called modify cart in order to perform the action against that array of values. And this last part of this syntax is saying that we want to seed the scan with an empty array of cart items. So that starts it off as that array. So first, a tip: anytime we want to maintain an array of data, we can use a scan. So what does our modify cart look like? It would look something like this. If the action is add, we're going to use the spread syntax and spread the items from the cart into a new array and add the new item. On an update, we go through each item and we identify whether it's the changed item. And again, we're using the name because these don't have IDs. So we look at the first item in the array where you changed no, so it's going to put it in the array. Next item where you changed no, it's going to put it in the array. Third item changed yes, okay, we don't want that one, we're going to throw it out. We're going to pull the changed one, stick it in that position. Then go to the fourth one, no, it's not changed, put it in. So that's what we're doing there. For delete, we simply filter out all but the deleted one, and that gives us that. And if we have an operation that's not one of the three we're expecting, we just simply create a new array with all the items. Okay, so cart component reactivity, we can update the quantity, and that's going to go through that code to do an update. We can also click on the X to remove it from the cart, which will use the delete functionality that we just talked about. But we also have this reactivity going on over here where it's maintaining the subtotal, and it's also maintaining the count of our cart items. So how is it doing that? How do we update the cart calculations? To react to a change in the cart, we can do a subtotal, which takes our cart items and it uses a reduce to total all of that up. Our delivery fee is based on the subtotal. Our tax is based on our subtotal because we need to ensure that the empire gets its appropriate fees here, and we need our total price. Again, since we want to react to multiple streams, our subtotal, our delivery fee, and our tax, we're going to use combine latest so we can work with all of those three streams together and be notified when any of the three of them change. Lastly, we're going to look at how to validate the design. This isn't something that every company needs to do, but some companies are interested in having a validation step. So one way that you could do that when you're dealing with reactivity is looking at degrees of freedom. A component has state, which is its variables, and it has equations, which express those variable relationships. So degrees of freedom is the number of variables that fully describe a component's state. And it's calculated by taking the total number of variables and subtracting the total number of equations. That leaves you with the variables that aren't defined by an equation. And those are then the minimum number of variables that fully describe the component's state. It often represents what the user can change. Let's walk through an example. So here we've got the vehicle list and the vehicle detail components. The vehicle classes, that's our drop-down list here. That is not actually a variable, it's an invariant, it doesn't change. So we don't count that one. Our selected class, of course, changes. Our list of vehicles, since it's filtered by the selected class, that changes. Our selected vehicle changes, and the selected film changes, the list of films here. So we have 1, 2, 3, 4 variables. If we then look at equations, our vehicles have an equation based on the selected class. So they're going to react to that selected class. They're not an independent variable. And the films as well are based on the selected vehicle. They are also not an independent variable. So we have two equations. So our degrees of freedom, 4 variables minus 2 equations is 2 degrees of freedom. So our application can set and react to those degrees of freedom. In our example, it's changes in the selected vehicle classification and changes in the selected vehicle, which maps to our 2 behavior subjects. So we can confirm that our vehicle list and vehicle detail have 2 degrees of freedom defined by these behavior subjects. Our car total component, looking at a second example, it has the cart items, which is definitely a variable, our subtotal, delivery fee, tax, and total, for a total of 5 variables here. And it has 4 equations. Each of these can be calculated from our cart items. So 5 variables, 4 equations, that gives us 1 degree of freedom. And that is our changes to the cart defined by our subject here. So if our original design had separate subjects, one for add, one for delete, one for update, this might give us an indication that there really should only be 1 degree of freedom, that we would only have 1 subject or behavior subject that we would need to work with for that part of the design. Okay. With that, my Twitter is here. If you want the link to the sample code for the sample application that I did, you can find it there on GitHub. And I also have a link to some YouTube videos I did on RxJS. Thank you very much.
Hi, I'm Joe Weems. Thanks for checking out this video from EnterpriseNG 2021. Online conferences were great, but it's time to get back in person. See your old friends, make some new ones, and take your career to the next level. Head over to ng-conf.org to get your ticket. See you there.